Good afternoon, everyone. We're just about to get started. Good afternoon, everyone. We're just about to get started. Good afternoon, everyone. We're just about to get started. Well, it's a pleasure to have all of you here today. I look forward to hearing from each presenter. And first of all, I'd like to say my name is Dr. Andrea Mayfield. I'm with the University of West Alabama, and I am in the Department of Engineering Technology. Several things that I wanted to start with today. Let me introduce the format of the session. So as we begin, what I will do will be to call on the presenter by abstract number and title. And I will give the presenter co-host permissions so that the presenter will be able to share their screen. Also, as the presenter comes up and begins to deliver their presentation, please introduce yourself by name and then proceed with speaking. I'm going to be keeping time for the presentations, and you will all have approximately 9 minutes. You'll get a warning at 9 minutes, and you will have approximately 2 minutes beyond that warning, and that warning will be an alarm. You'll hear a bell, a ding. I'm going to use my cell phone. How original, right? But you will get a warning, and at that point, if there is time, we will move on to question and answers. The way that question and answers will be conducted is that for those of you who have questions, you will type those questions in the chat. Those questions will be answered in the order received. So without further ado, let's get started. I want to welcome all of you to the 2025 Academic Research Conference. It's an honor to have 8 presenters with us today who will be sharing their research. To control background noise, I'm going to make sure everyone is on mute. That will limit background noise as speakers are presenting. So today, the first presentation, our first presenter is abstract number 61. Abstract 61 is entitled K-Means Algorithms and Industrial Predictive Maintenance Strategy Proposal of a Conceptual Research Model to Transform Industry 4.0 in Morocco. So I'm going to turn over the controls here to our speaker. All right. And the controls are yours.
Hello.
Hello, I can hear you.
So am I the first presenter?
You are going to present first today. It's a little bit out of order, but we're going to go with who is here. So let's start with you, okay?
Okay. So thank you so much. I will share my presentation. Um, Do you see the presentation, please?
It says that you have started your screen sharing. We don't see it quite yet. There you go. We see it now.
Is it clear for you, please?
It is. You might want to maximize your screen.
Yeah,
Uh-huh. That's perfect. Yep.
good. So, hello everyone. I am pleased to present our research on the impact of integrating K-means algorithm into predictive maintenance strategies and their role in improving industrial performance within Industry 4.0, particularly in Moroccan factories. Today, artificial intelligence is transforming industry. With new technologies, companies can optimize their production and improve their competitiveness. So AI is essential because it helps analyze large amounts of industrial data. But there is a gap because we still know little about the exact impact of some algorithms like K-means on industrial strategies. And this is especially true in predictive maintenance, which helps anticipate failures and prevent production stoppages. So our study asks a key question, and how does integrating K-means into predictive maintenance affect the performance of Moroccan factories, and what strategic mechanisms explain this impact? So to answer this, we built a strong research model based on a detailed analysis of existing studies. We developed clear hypotheses and used a quantitative approach to better understand the links between AI, K-means, and industrial strategies. Today, Moroccan industry is entering the era of Industry 4.0, where artificial intelligence is revolutionizing production. Factories are becoming more connected, more automated, and more efficient. In this context, predictive maintenance plays a key role. And what's its main goal is to reduce costs and improve industrial efficiency. As Porter explains, cost reduction is a powerful way to strengthen a company's competitiveness. But what makes it so effective? Unlike traditional methods, predictive maintenance uses smart sensors to analyze data in real time and anticipate failures before they happen. With artificial intelligence and machine learning, this approach improves equipment availability and prevents production interruptions. And the result, more efficient, high-performing factories ready to face Industry 4.0 challenges. In addition, machine learning is a powerful tool for reducing industrial costs. It helps detect hidden inefficiencies by analyzing large amounts of data. By processing past and real-time data, these algorithms continuously suggest optimizations. In predictive maintenance, they help anticipate failures, reducing unexpected downtime, repair costs, and operational disruptions. By directly lowering operating costs, machine learning strengthens companies' competitiveness and becomes a key pillar of Industry 4.0. So, we know that K-means is an excellent tool for data segmentation, but its strategic role in predictive maintenance and resource optimization remains understudied. This research gap limits our understanding of its real impact on Industry 4.0. To address this, we have formulated 5 hypotheses to analyze how K-means influences data segmentation, interacts with other algorithms, and improves industrial performance. So to support our research, we rely on two key theories. The first one is organizational learning theory by Argyris and Scone, and the complex systems theory by Bertalanffy. The hypothesis follows a progressive logic. So the H1 states that the effectiveness of K-means in predictive maintenance depends on the quality of collected data. The H2 explains that combining K-means with supervised algorithms enhances failure prediction. As a result, H3 argues that K-means helps reduce costs, but only if companies adapt their processes to the identified clusters. And finally, H4 highlights that K-means efficiency depends on the homogeneity of industrial conditions. The more diverse the environment, the more limited K-means becomes in optimizing resources. So, to answer our research question, we have chosen a quantitative study. The goal is to precisely measure the impact of K-means in predictive maintenance on the industrial performance of Moroccan factories. This approach helps us establish clear links between data, resource optimization, and cost reduction. To achieve this, we use an advanced statistical method, is the structural equation modeling. This tool allows us to simultaneously analyze multiple complex relationships, whether visible or hidden. With this approach, we can validate our hypothesis with precision and gain a better understanding of how K-means influences Industry 4.0 in Morocco. So this research model is highly relevant for understanding the impact of K-means in predictive maintenance for Moroccan factories. It is organized into three key variables. So the first one, the independent variable, is K-means integration, and this measures its use and data quality. It would also be useful to consider how frequently the models are updated, and this influences their effectiveness. The second variable is the moderator variable as strategic mechanisms, and this examines factory adaptation, cluster quality, and resource management. A valuable addition would be to assess how employees accept and apply K-means recommendations. And the third one is the dependent variable as industrial performance, and this model evaluates cost reduction, productivity improvement, and return on investment. Another interesting factor is to explore is whether works for find these tools easy and practical to use. Overall, this model is very solid, and with some adjustments to include human factors and model updates, it could even better reflect the real impact of K-means in Industry 4.0. So let's move for the study process. So this table presents a well-structured methodology to analyze the impact of K-means in predictive maintenance. The process begins with data collection through a questionnaire, followed by analysis using two methods: the confirmatory factor analysis to check variable reliability, and structural equation modeling to test relationships. The results interpretation happen in 4 steps. First, we can assess the overall model quality, then analyze K-means direct effects on industrial performance. And next, we examine indirect effects, identifying key factors such as cluster quality and resource optimization. Finally, we test the hypotheses to verify their validity and impact. So we can say that this rigorous approach ensures precise and actionable results, helping to better understand K-means' role in Industry 4.0. To conclude, this study examines K-means' impact of predictive maintenance in Moroccan factories through a model based on Industry 4.0, as we said. So we formulated hypotheses on its direct and indirect effects, especially through organizational process adaptation. However, some limitation exists. Cluster reliability depends on data quality. The quantitative approach does not fully capture organizational complexities, and the Moroccan context may limit results generalizations. So to go further, it will be useful to combine Cummins with, for example, other advanced algorithms and adopts a mixed method approach to gain a more comprehensive understanding of its impact. And here are some references that I used in my paper. And thank you.
Thank you very much. Now we'll go for question and answers. If anyone participating today has any questions, if you would, please direct those to the chat. And then we'll move forward to the next presenter. Thank you very much.
Thank you so much.
All right, we'll move on to the next presentation. Give me just a moment to change the controls here. All right, we're going to move on to abstract number 63. This one is entitled Urban Expansion and Development of High Value Added Industries, Localization of Small and Medium Enterprises Operating in Information Technology in the City of Rabat, Proposal for a Measurement Scale Based on Structural Equation Models. All right, you should have the controls.
You hear me?
Yes, I hear you.
Okay.
Very good.
I will share my screen. Is
All
that
right.
okay?
Yes, absolutely.
Yeah. Hello, everyone. Thank you for being here today. I'm Bahattin Haroussi, PhD in Economy and Management Sciences, and I'm gladly excited to present our research in the Academic Research Conference. Our study titled Urban Expansion and Development of High Value Added Industries, which is the localization of small and medium enterprises operating in the information technology in the city of Rabat, proposal for a measurement scale based on structural equation model. By the way, me and my partners, namely Ismail Maroufi and Zin Btrisi, have worked on this research for many months ago, and we decided to contribute and communicate in this international conference. The choice of small and medium enterprises refer that they are the most representative in the Moroccan economy and industry by 95% and 90%, and they contribute.
Excuse me just a moment. Did you want to
Yeah.
share your screen?
Isn't shared now?
No, we don't see you sharing the presentation.
I already did it. I check. Okay. I think. Wait. Is that okay?
That's it. Yes.
I think I should come back for the first slide. No?
All right. That's fine. You might want to maximize your screen and
Yeah,
certainly.
Yeah, I just mentioned that me and my partners have worked on this study for many months ago, and we decided to contribute and communicate it in this international conference. The choice of small and medium enterprises refer that they are the most representative in Moroccan economy and industry by 95% and 90%, and they contribute to employment, export, and investment. Rabat, as a political and administrative capital of Morocco, is characterized by such a high population density, urban growth, and administrative concentration. This finding or this observation lead us to formulate the central question of our research. How does urban expansion impact the localization of small and medium enterprises operating in the IT technology localized in the city of Rabat? Based on this question, we grounded several theories, namely territorial economy, which explain that the localization of small of economic activities based on strategic assets and resources. Urban economy proposed by Van Tenen and Alonso highlights the spatial distribution of economy in the city. Agglomeration economy developed by Marshall and Anderson emphasizes the benefits of business clustering in urban areas such as reduced costs and innovation. And finally, the new economic geography by Krugman studied the forces of agglomeration and dispersion to avoid competition and access to multiple markets. Based on these theories, we formulated the hypothesis of our research. First, urban expansion in Rabat fosters the emergence and the growth of small and medium enterprises operating in the IT technology by creating a favorable environment for their activities. And the second one is this favorable environment, namely perceived position of Rabat impacts the localization of small and medium enterprises operating in the IT technology. And here are the conceptual model of our research. In order to test this hypothesis, we adopted the following methodology. First, a post-positivist epistemology and hypothetical deductive approach. The data was collected through a multi-scale questionnaire targeting small and medium enterprises localized in the city of Rabat. For the confirmatory factor analysis, we used the structural equation modeling to analyze the relation between urban expansion, territorial positioning, and localization, and in order to validate our findings statistically and ensure reliability.
Baha, I'm sorry, can I disturb for just 1 second? I'm sorry. Can you make
Yeah.
it on a presentation mode so the slides can move? It's not moving for the audience.
It's not screened.
No,
It's not shared on the screen.
it's just the first slide that is showing that says introduction. Just make it in a full screen mode.
Is this okay now?
No,
Isn't shared. It's so
it is
weird.
shared, but we just see a slide number 1 or whatever it says introduction. SME represent. Now it's moving. Now it's at the top.
We're
So it
seeing
will
your
be-
outline.
What is the problem here?
We're seeing your slides to the
It's
left of the
okay.
screen.
It's okay, I think.
Stay to the right side of the slides and move it from there.
I will back now.
Okay.
It's okay now. So should I have to repeat?
No, in the bottom, do you see that like positive and negative? And that says 67. Just a click on that, like a little window, looks like a projector, a TV. Bottom right hand side. Yes, a little bit to the left, to the right.
From here?
You look at the bottom of the screen. where you see the 67%, there is a box on the other side of the percent that will open it up.
Should I continue or I can repeat from the first slide or what I have
Go
to
ahead
do?
and continue, but navigate through the slides, please.
Yeah,
Not the
well,
sidebar.
that's what I do.
Okay, go ahead.
Okay, developing a robust measurement scale was critical and crucial to our study. So we followed the paradigm of Churchill. First step was to specify the domain of contrast and generate item through a literature review. And as we mentioned in the methodology, the collecting data was through multi-scale questionnaire. We used the Cronbach alpha and exploratory factor analysis to provide the measurement scale. And finally, we used the structural equation model as a confirmatory factor analysis to validate our measurement scale and the hypothesis of our research. And here, the exploratory analysis of the first construct of our conceptual model, urban expansion. The means shows range from 30.1 to 30.5, which indicating or reflecting the high conception or high perception of the concept. The standard deviation ranged from 1.1 to 1.5, which demonstrate the moderate reliability of the conceptual or the items. All items shows a negative skewness, which explain that the data is skewed to the right. The coefficient of kurtosis indicate a Placatric distribution, true and negative value. The coefficient of Cronbach alpha demonstrate an internal consistency of the items, and the factor analysis of Chemo index and Bartlett test indicate the factorability of the items. And finally, the scale is unidimensional through 72% of the variance. This table provides the exploratory analysis of territorial positioning. The means show data that explain the hard perception of the concept territorial positioning. The coefficient of Cronbach alpha always show internal consistency of the items, namely innovative ecosystem, investments, climate, and specific positioning. The factor analysis of Chemo index and Bartlett test indicate the suitability of the items. And finally, the principal component analysis demonstrate the unidimensionality of the concept by 71%. This table demonstrates the exploratory analysis of the localization variable. The Cronbach alpha demonstrates a high internal consistency of the items, economic attraction, economic dynamism, and strategic connection. The Chemo index and Bartlett test demonstrate the factorability of the items, and the principal component analysis demonstrate that one component can analyze other with 63%. The confirmatory factor analysis by using the structural equation model confirm the hypothesis of our research. While urban expansion has a positive and significant impact on positioning, while strongly influence the localization of small and medium enterprises operating in the IT technology localized in the city of Rabat. The R squared confirm the fiability and the quality of our model by 77% of
Excuse me,
explanation
presenter.
of yes.
It's time for us to move on to the next presentation. I'm sorry.
But you arrest me for me once I should continue my presentation. You arrested me and I back for the first slide and back for the next. It wasn't my problem. It wasn't my fault.
For
Can I
the,
continue? Can I continue to the next next
we've
finding?
got to move on for the sake of
Yeah.
time so that every presenter has the same amount of time
But
to,
you stopped me
yeah,
for many time. I should continue my presentation.
and we'll see
So
what we can do toward the end.
I can.
All right, our next presentation, abstract number 64. This is titled Enhancing Security and Intelligent Transportation Systems, AI-powered CNN model for multi-class intrusion detection in Venice.
Hello, are you
Hello?
hear me?
Yes, I see your presentation.
Okay. So hello everybody, I'm Khadija Mu'tasim from Shuaib University of Morocco. My presentation takes place under the title of Enhancing Security in Intelligent Transportation Systems, AI-powered CNN model for multi-class intrusion detection in Venice. This presentation begins with an introduction, followed by overview of Venice components. Next, the proposed intrusion detection model is presented, along with an analysis of the results. Finally, we conclude. So Venice enhance intelligent transportation, but face security threats due to wireless weaknesses, recurring robot IDS. This presentation introduces Genet, CNN-based model leveraging RNN and serif gaussian to improve multi-class intrusion detection. So before discussing our model, we will first present the components of VANET network and the different communications modes. There are three main components in VANET. First, roadside units are devices act as access points, enabling communication and traffic information exchange with user. Second, central authority serves as the trusted authority in VANET, managing security devices like certificate assurance, communication keys, and data storage. Third, vehicles. They are intelligent vehicles with very advanced technology like GPS, radars, processing platform, human-machine interface, communication equipment, and data collection, such that the main devices of the nodes are authority units, an electronic device in vehicles ensuring central authority communication, onboard units, a device in smart vehicles for data exchange and location tracking, and the transfer of information and data between vehicles is carried out using different communication modes. First, by vehicles, it's a communication in the vehicle itself between OBU and AU. Second, ad hoc communication. There are two types of communication in this mode, V2V, direct communication between neighboring vehicles, OBU, V2I, communication between nodes via roadside units relay. And the third is infrastructure communication in the global vehicle network or with the internet. The goal of VANET is to improve road traffic and drive safety. To address this, our study proposed a Genet intrusion detection model, adopting convolutional neural network to effectively detect and classify cyber attacks and integrate a data structure which can preserve relevant information at long distance and improve the detection of complex attacks in dynamic environments. In this study, we use NSL KDD, include 41 features, of which 38 are numeric and 3 are symbolic. And the GeneT model consists of three main phases. Phase 1, data preprocessing. We start with unifying data, where the three symbolic features are converted into numeric features. We apply one hot encoding, from where the 41 features are transformed into 122 features. Next step is normalization. Then we apply smooth, is used to balance the class by generating synthetic sample for the minority class. Finally, the preprocessed and balanced data is transformed into image format to be used by the SAN. After preprocessing, the image passed through two parallel paths. Each path apply 1x1 and 2x2 convolutional layers, batch normalization and GLU activation, with a cutting mechanism using sigmoid and GLU to enhance future extraction. The outputs are fused processed tools, the output and max pooling flattened, and passed to the dense layer before classified into 5 categories: normal, DOS, U2R, R2L, and Pro. Phase 2, the GeneT model is trained on pre-processed data to learn patterns in network traffic and detect intrusion. Phase 3, the trained model is tested on a separate dataset, classifying traffic as normal or attacked, with performance evaluated using accuracy, precision, local, and F1 score. The results show an accuracy of 98.57%, which corresponds to a loss of 1.42%. Furthermore, the accuracy local and F1 score metrics for those probe R2L and U2R classes are almost identical, while those for the normal class are slightly lower compared to the 4 attacks type. And to compare the model prediction with the actual results, we have the confusion matrix. We observe that the model detects 99% of the number, 97.18% of those, and 99.49% of the probe attack were correctly predicted. So the various algorithms based on convolutional neural network have been applied to intrusion detection, including models such as CNN IDS, the MCNN, CNN by LSTM, CNN without CRF, LCFS. On this study have evaluated the accuracy of different algorithms in this domain. The following table and figure provide comparison of these models with our GeneT model. And to conclude, the proposed VANISH model detects 5 attack types using instability, leveraging a control mechanism to filter low-level data. Future work aims to enhance execution speed for better threat response in dynamic environments. I thank you for your attention.
Thank you. Are there any questions? That was very impressive. Thank you for sharing that.
Okay, thank you.
All right, we'll move on to our next presentation. This one is abstract number 66. It is titled A Novel Method for Accurate Medical Image Segmentation. All right, you should have control.
Hello, everybody. I have the honor to present my work entitled A Novel Method for Accurate Medical Image Segmentation. I will start with the introduction, mathematical background, the proposed method, the numerical results and discussion, and finally the conclusion. With the rapid progress of medical science and the arrangement of databases, medical imaging has become essential in the diagnosis and treatment of diseases. However, the current practice of manual reading and analysis is laborious, time-consuming, expensive, and error-prone. It would be more desirable to have a computer-assisted system capable of automatically making diagnostic recommendations. Despite technological advances in the medical field, the study of the human brain is a difficult problem and remains a current research. MRI is one of the most used diagnostic modalities for observing the brain area. This technique allows observation with fine resolution of brain tissues, which are composed of white, gray matter, and cerebral fluid. For a reliable diagnosis, precision is important, and in terms of image analysis, it is necessary for the segmentation to be precise. The objective of segmentation is to assign to each pixel a class label among C classes. However, MRI suffers from a large number of artifacts which make their segmentation difficult. These artifacts are mainly due to noise and intensity in homogeneity. Given the ambiguous and imprecise nature of the information provided by the different MRI sequences, fuzzy clustering technique adapts well to segmentation of brain tissues. Fuzzy clustering allows the progressive membership of pixels to clusters in the interval 0-1. This technique is based on minimizing the interclass variance and their three constraints. The first constraint ensures that the degree of membership must be between 0 and 1. The second normalization constraint ensures that the sum of membership degrees of each pixel to all classes is equal to 1. And the third constraint ensures that no class must be empty, and M is a parameter controlling the degree of fuzziness. The kernel fuzzy CMIS modifies the objective function of fuzzy CMIS via the phi transformation to project the pixel into a higher dimensional space, which increases the chance that the clusters become linearly separable in the projected dimension. This method is sensitive to noise and intensity in homogeneity. Indeed, many methods have been proposed to modify this objective function. One recently proposed a modification of this function. This model joins the spatial information constraint term to automatically control the effect of neighborhood pixel on the central class. This method works well for image segmentation, but it is somewhat insufficient because it does not pay any attention to correct the bias, and it takes a lot of time for segmentation due to spatial term. In order to solve these problems, we proposed a new objective function based on the kernel fuzzy CMIS. In the objective function of kernel fuzzy CMIS, we adopted the Gaussian radial basis function kernel. In this kernel, the function in this function, the sigma parameter can we will affect the final result to some extent, and since sigma is presented as a dispersion, the variance of the data is used to estimate the sigma squared. When we adopted the Gaussian kernel with our radial basis, we deduced that the kernel function kxx is equal to 1, and consequently, the simplified objective function of kernel fuzzy CMIS is given by equation 2. An exponential type distance is monotonic and can be robust to noise when 1 minus the kernel function is used to replace the Euclidean distance. To significantly reduce the amount of calculation performed during the segmentation process, we applied local filtering to each pixel before the segmentation process, which is formed from the original image and its local spatial neighborhood. And the alpha parameter controls the trade-off between the original image and its corresponding average filtered image. And in the MRI images and in the presence of bias field, the observed images are modeled as a product of the true image and a bias field with additive noise. Ignoring the noise term and applying the logarithmic transformation on both sides allows the artifacts to be modeled as an additive Bayes field. And by integrating the Bayes field model into the kernel fuzzy Siemens, we will be able to iteratively estimate both the true intensity and the Bayes field from the observed intensity. We have a new objective function to minimize in the presence of Bayes field. Then we added the entropy term to summarize the average information for the occurrence of a data point belonging to the corresponding class. So our objective function is defined by this formula, where W is a positive penalty term parameter. In order to find the membership function, biases, and prototypes, we adopt an iterative optimization algorithm, which minimizes GM under the normalization constraints. The proposed objective function is solved by this theorem. If X contains at least distinct data points, then 3 necessary but not sufficient conditions to minimize the objective function GM with the normalization constraints lead to these iterative updating formulas for the prototype, the partition matrix, and the Bayes field. The minimization of our objective function GM represents a nonlinear optimization problem. Therefore, the updating formulas U, V, and B are obtained by introducing Lagrangian multiplier associated with the normalization constraint by cancelling the partial derivatives of the Lagrangian with respect to the parameter of our model. Sufficiency is also proven by examining the Hessian matrix of the Lagrangian of the proposed objective function GM, evaluated at U and with V and P are fixed. In the same way, we have shown that the updated Bayes and prototype formula are sufficient conditions to minimize GM. The proposed algorithm is carried out iteratively in different stages. The process began by randomly initializing the fuzzy partition matrix U such that the normalization constraint is ensured, and by initializing the initial cluster centers and the biases to 0 values. Until convergence, cluster center, the fuzzy partition matrix biases are updated. The process stops when the GM criterion stabilizes. When the algorithm has converged, the defuzzification process converts the fuzzy partition U into a hard partition. The performance of our model was tested on 2 brain MRI images corrupted by different levels of noise and intensity and homogeneity. And the brain tissue segmented by our model was compared with the ground truth and with six recent algorithms. The parameters of our model are defined as follows. And the metric used to evaluate the predicted segmentation against the reference segmentation are DICE, G-mean, and accuracy. These figures represent the segmentation results of the teletissues and the overall segmentation obtained by different algorithms on the first MRI image, corrupted with 9% of noise and 20% of the intensity in homogeneity. From the results obtained, we can see that the 6 existing algorithms are incapable of classifying certain pixels affected by noise, while our model is closer to ground truth. It clearly justifies the efficient segmentation of the teletissues and the reduction of noise. This table represents the segmentation results in terms of precision obtained by the different measurements of the first corrupted MRI images with 5, 9, and 13 and 20% of noise, each having an homogeneity of 20%. The result reported in this table show that our algorithm outperforms other methods. We also evaluated our model on another image by increasing the intensity in homogeneity from 20% to 30%. The segmentation results by our model, obtained by our model by the different measurements outperforms other methods. The effectiveness of the proposed method was also tested in terms of execution time. The results show that the proposed algorithm only requires 19 seconds. This thanks to the use of local filtering of each pixel before the segmentation process. To conclude, medical imaging is one of the areas of medicine that has proven its usefulness for over the last 20 years. The segmentation of MRI medical images is a very broad area of research that constitutes a necessary step in the treatment of brain tumors. MRI images contain intensity, inhomogeneity, and noise can lead to inaccurate and unreliable segmentation of results. In this context, we propose an efficient fuzzy clustering method for automated segmentation of brain tissue from MRI corrupted by noise and intensity inhomogeneity. Here are some references used in our work. Thank you for your attention.
Thank you so much. What we'll do is we will, at the end, when we finish all presentations, I'll ask the judges if they have any questions for all of the presenters, and we will address them in that way. Due to technical difficulties prior, I'd like to call Abstract 63 back to share his screen and share his research, if he would like to. I'm going to go ahead and make you a co-host where you can do that. All right, you should have controls to do that at this time. Number 63. Abstract 63. Would you like to pull your presentation up and proceed? All right. What we'll do now is I will proceed to the judges. Please feel free to move forward with any questions you have for Abstract 61, 63, 64, and 66. And I'll just open the floor to you. Just unmute and begin with your questions. We'll do this verbally.
Good evening.
Good evening.
Actually, amazing presentations.
Yes.
I enjoy it. I would like to start with the great job of improving the MRI images. It was amazing, and it can improve the MRI diagnosis for better brain treatment and health improvement. But I want to ask, can this be integrated on a practical conditions to MRI and used in hospitals? This is, I think, 66, Abstract 66. Is my question clear? I asked.
Can you unmute?
Yeah, I asked if this study can be really integrated in practical conditions in hospitals and be really used for better brain treatment and health improvement, or it's only can be. I saw she used it for like a test, but can this be really integrated in hospitals? Are there any challenges for that? I think she left.
I think she did. Yes.
Is
Do you have
Khadija here?
additional questions?
I have a question. Is Khadija still here? She's number 64.
She's here.
Um, I had two questions, but I'll just ask the one. How did you decide on your 41 features for your algorithm?
Khadijah, could you unmute?
Maybe they have problem in unmuting.
Can you,
Maybe.
Kaja, can you unmute and answer the question? You should have co-host ability permissions.
Well, I have a quick question about the abstracts we've had so far. Um, we have not had number 60 and number 62, right?
We didn't have number 60. We didn't have 62.
Okay.
We didn't have 65 or 67.
Okay, I just
Yes.
wanted to be sure.
Yes, correct. Do any of the other judges have questions?
I was talking if I can. We are asking, but they are not here. But I don't know. Regarding 61, Fatima, it was amazing, but it was maybe amazing work. Well done. But if she tried to show some parts of the questionnaire, it would be better. Not explained clearly. So I was about to ask her about the results, but it looks like even Fatima not there. Fatima Zahra.
Fatima, can you unmute, please?
They are not allowed to unmute.
She's got co-host abilities.
It's okay. But actually, it was a great presentation for these students, and they expand really a future research, ranges that can be really practical and useful.
Well, please join me. We'll move on to Dr. Donna. Do you have any questions for anyone? I'm trying to make sure they can unmute. Dr. Donna, you must be on mute.
Me now?
I hear
Oh,
you now.
all right.
Yes,
Yeah.
sure do.
So, yeah, first of all, the students have done a really good job in presenting their stuff. Of course, there are some glitches here and there, but the wide variety of topics that they have chosen is commendable, and especially with respect to 66 and 64, they have done a really good application. Hopefully, the application is uh, viable in that field in terms of the intrusion detection as well as this image segmentation. They are good, and I would really like to see more in terms of the slides on 63, but unfortunately the student could not show the screen, but that was interesting approach as well, and 61 as well, the k-means algorithm. So students have done quite a bit in terms of algorithms, and that's where my questions were. And if anybody is here, maybe we can have a discussion on your questions.
All right, see if you can unmute yourselves.
I guess for 61, she has answered me initially where I asked if this, I asked her a question on the chat if there is any data collected, to which she has responded that this is a part of research which is for future articles. So I guess I'll take that as an answer. And for 63, I think 63 is here.
Yeah, I'm
Yes,
here.
you can show
Yeah.
us the
Yeah, I'm here.
presentation a little bit. The slides, Cronbach Alpha, and the analysis was while you were talking, you were not navigating in the slides. So it was a
No, yeah, I think it was a problem about connection on synchronization. But I passed
Yeah.
the slide, but my friends has been in the Zoom and told me that there is no screen, just obscurity, and that's all I wanted to share. Thank you for being
Can you
here.
share?
And
Can you show us, or there is no time? I want to see only the model for the hypothesis. If you can, if you cannot, it's okay.
how can I share it right now?
If it's
Wait.
allowed, ask the moderator.
You-
I cannot.
You may. You should have co-host privileges
If
right
there is
now.
permission for that.
What? Wait.
You should be able to pull it up and share your screen now.
Okay. The final conceptual or the first? The confirmed
I want to
or
see the model, the final.
the final, yeah.
Yeah. Conceptual
Yeah.
framework. Yeah.
Is it shared? Wait. Wait.
It's okay.
It's okay.
It's good
It's
that
okay
you
now?
made factor analysis.
Yeah, the
And
structure.
I think it would depend on a Cronbach alpha. So it's good,
Yeah.
even this one. The results are good. And the arrangement, there is little, problem was in the presentation, but it was okay. I tried my best to focus on the analysis while hearing you. But really, thank you many thanks for you, for other students. They knocked many or triggered many important disciplines regarding the urban design or traffic or MRI and healthcare, and many other disciplines which are very important and vital for future improvements. So I was trying to look at this one, and thank you so much, Baha. Thank you.
Thank you. Thank you. It was a great pleasure to share finally I shared the confirmatory factor. It was the
Yeah.
it was the main analysis of my research, and it's finally it's okay.
Yes.
Yes.
I'm happy that you did. Otherwise, you'll be sad tonight.
I didn't understand what was the problem, but finally it's okay. Yeah.
Would you like to share some of your other slides?
Maybe if you can go very quickly through them.
Yeah, it was just the final. It was the final analysis of my research that I confirmed my conceptual model. I just want to share that I used the R squared. Yeah, the R squared demonstrate the quality and the fiability of my model by explanation of urban expansion with 77% and 82% of positioning and 64%. This illustrates that the model is feasible and good.
Yeah, especially for positioning.
Yeah.
It is the higher, closer to one. Okay.
The discussion of my result, it was that my study or has confirm or highlights the impact of the urban growth and urban expansion on the localization of small and medium enterprises. Rabat, as you know, is the capital of Morocco, has a strategic urban city, including development of urban projects, permit the appeal of IT businesses. And according to the theory that I developed in the framework theoretical, we confirmed that the theory of territorial economy, which emphasizes the role of concentration in urban areas. That's all I have to share. I can also talk about that our study share an important implication of for policymakers and stakeholders that urban infrastructure are crucial for the localization of enterprises in general. The territorial marketing and territorial positioning is a significant and strategic tool for territorial issues, and theory of territorial economy and urban strategy is critical for the development of economy in urban areas. That's all. The conclusion sum up all the finding or observation that I shared on the first slides. That urban expansion positively impacts the localization of the small and the medium enterprises in the IT technology. Territorial positioning driven by urban strategy is a key tool for the growth of small and medium enterprises. And this finding highlights the importance of urban development in the emerging of economy in the city. And we recommend for future researchers to evaluate the long-term impact of urban expansion in digital transformation for the small and medium enterprises. And that's all I shared. And thank you for your attention here.
Thank you so much.
Thank you.
Thank you so much.
Do any of the other judges have questions?
Quick question here. Thank you for the presentation. Do you have a slide, or can you elaborate on what data points or data set that you use for quantifying the urban expansion?
Which slide, please? Which
that's,
slide?
That's where I need your input is, can you explain based on the research, what data set or what have you used for quantifying urban expansion?
Can you tell me which slide is this?
Maybe go back up. Go back.
That's okay.
Okay, there. Okay. I
Yeah.
guess.
Yeah.
All right. Yeah. Can you tell me on the left-hand side what is the item description? Or what was the idea of choosing these for the analysis?
Yeah, it's according to the literature.
Okay.
We talk about these items. Yeah.
Yes.
It was according to the literature and the status of the capital of a capital. It's okay. Did I answer your question?
Okay. Yep.
I don't have any questions.
All right. Well, thank you so much. Good job.
Thank you.
At this time, I'd like to thank all of the presenters for being here and for sharing their work with all of us. Great job. It's amazing. And
Yeah.
I know you will continue to do great things. So thank you.
Thank you for being here today. Thank you.
And this will conclude our session.
Dear moderator, what about 60 and 62 and 65 and 67? We leave them empty, yes?
Yes, they did not, they were not here for the session.
My comment, they did not present.
Okay.
I just
Can I ask you, please, what is the number of my presentation?
Fatima, 61.
61, yes, that's correct.
Yes, 61. Okay. C'est bon.
Fatima, can you tell us little about your results? I was looking for you.
Yes, sure.
You told us about the methodology, and you told us very quickly about the way you collect the data. The questionnaire, if I were you, you did amazing job, really, all of you today. But
Thank
it was
you so much.
if you you present in one slide little about the questionnaire, you know, and at the end, I did not catch up the fruit of the results of your research. Again, it was again a good presentation, nice topic, important, related to industry. But if you can little bit tell me about the fruit of your results.
Yes, sure. First, thank you so much all. And I just have one little remark is that normally my subject should be part of economics and social science, not engineering. The second, la deuxième
Okay,
chose,
we have
it's that
experience in this field.
my
It's
it's
my
that
case, by the way.
my sorry.
It's
Sorry,
okay. Yeah, it's okay. Proceed, please.
the second thing that I would clarify is that my paper is just a proposal model for future research.
Yeah,
It's
this
just
is
a
why.
proposition
Yeah.
for a future, for another article where we can apply what I suggest in this communication.
Yeah. So because of
So
this, you
I
don't have
don't have
results.
results.
But
So I
Habib,
don't sorry. Are you here?
Go ahead.
Do
it's
you hear
good
me?
to put at the end expected results. This will just like, yeah, of course. Maybe in the future, if you have, it can be like in the future, expected results. It will make your research or proposal more strong. And the expected results you might reach. But again, thank you for your research. Thank you. Great job, all of you.
Thank you so much.
I have a question about the attestation. When we can, yeah? When we can get them? The
Get what?
attestation.
Say that again.
I talk about the certificate of the participation. Did you hear me?
Yes, you're inquiring about a certificate.
Yeah.
I will talk to Dr. Morrissey about that.
Yeah, it's okay.
Okay?
Because we
Okay,
are
thank you.
three participants in this.
Yes.
Yeah. It's okay.
Yes. I will talk to him about that.
Yeah, it's okay. Thank you.
Thank you all, and this concludes our session.
Thank you. All the best.